Okay, I think we are live. Hello, everybody. Welcome to the Things Stack Digital Twin webinar. I'll give it a second to make sure everybody gets in okay. Looks like we're streaming on YouTube and on LinkedIn. Hello, hello, hello. I'm really excited about today's webinar. I think we're going to showcase some really cool stuff. So, okay, I see that YouTube is live. I think LinkedIn is live as well. Hello, everybody. Welcome again to the Things Stack Digital Twin webinar. So in the Things Conference 2022, we built the world's biggest digital twin, where we showcased sensor data from lots of partners at the Things Conference in a 3D visualization of the conference venue. And so today we're going to go through how we built that using the Things Stack and Azure. So first of all, I'm Ben. I'm the technical content guy at the Things Industries. And like I said, we're streaming today on not on Facebook, I think, on YouTube, on LinkedIn, but there's lots of links, like useful information in the description on YouTube. So if you're watching on LinkedIn and you want to participate a little bit more, or if you're interested and want to register your interest, hop over to YouTube, and there you can see all of the links to find more information and to kind of register your interest. So at the end of this webinar, we'll also do Q&A. So I can see all of the chat in YouTube. And at the end, we have a guest who will answer questions about how we built this digital twin. So this is what we're going to go over today. Here is the agenda. First, we're going to talk about what we're going to build today. And then we're going to kind of ask the philosophical question, what is the metaverse? And we have Benjamin Kabe from Microsoft here to answer that in a little more detail. And then Benjamin will also do a quite in-depth hands-on digital twin tutorial to show exactly how we built that digital twin. And finally, I'll talk a little bit about the Things Conference and we'll do Q&A. All right, so for anybody just joining, you're watching the Things Digital Twin webinar. We are live on YouTube and LinkedIn. Please post your questions on YouTube, and we'll answer them at the end of the webinar. So today we're covering the topic of digital twins. If you don't know what a digital twin is, it's a virtual representation of a physical thing. In this case, it's a building, the conference venue of the Things Conference 2022. And our philosophy is kind of that you can't control what you can't measure. So the benefit of a digital twin is that you can actually represent this physical thing that you have in the virtual world. And in the case of the Things Conference, we then could see the temperature, the number of people, the humidity, and all of these different areas in the Things Conference. We have a lot of enterprise customers at the Things Industries who use this because it provides a lot of insight into their assets. I wanted to talk really quickly about GoldenEye, which is a collaboration using Microsoft Azure and the Things Stack that monitors thousands and thousands of homes in the UK. And then that's used to like trigger automatic maintenance calls if something is out of whack in these residences. Let's see, I have a little overlay, and then also on YouTube, there's a link where you can read more about that, and you can see a kind of cool practical use case of applying all of this sensor data. So pop over to YouTube if you're not there already. Check the links below for more information. Today, we're going to walk through building that digital twin that we created at the Things Conference 2022, and then Q&A at the end. So first, I'll play a little video that has a short overview of exactly what it was that we created, and then Benjamin's going to go into depth. So here we go. I'm Ben from the Things Industries. At the Things Conference 2022, we created the world's biggest digital twin. We took LoRaWAN devices from all of our partners and we placed them throughout the conference venue, and then we visualized them in Microsoft Azure Digital Twin. We did this using a native integration between the Things Stack and Azure IoT Central. Today, I'll walk you through how we created this digital twin, and I'll show you how easy it is to create your own powerful visualizations so you can easily see data from LoRaWAN devices. Let's get started. Okay, so this is what our visualization will look like in the end. So I'll give a quick overview now of the entire pipeline to create this, and then we'll go into it in detail in the webinar. So to create this, we start in the Things Stack. And we need to create an integration between the thing stack to get our LoRaWAN data into Azure IoT Central. So we go to our application, integrations, Azure IoT, and then we just have to copy some information and keys over from our Azure IoT Central instance into the things stack. We have documentation that explains exactly how to do this, but it's really simple. It's just a matter of copying some keys. Once that's done, all of the data from these end devices here will automatically be published to Azure IoT Central. So here in IoT Central, we can see devices, and these have automatically been created as soon as the devices uplink. We can also create device templates, which allow us to standardize data, attach metadata, and do other kinds of operations to classify these devices. This is great for creating dashboards and kind of massaging data, for example, from different types of temperature sensors. Once we have our data here in IoT Central, we need to use data export to get it over to Digital Twin. So in data export, in destinations, we've just created a webhook endpoint that pumps all this data over to the Digital Twin as soon as it gets updated in IoT Central. In the actual data export, we can also massage our data and write transformations, just in case we want to attach any extra metadata. Benjamin will again go into more detail in the webinar about how he used this. Now, whenever device data changes, that webhook will automatically send the data over to Digital Twin. Here in the Digital Twin, we can see the aggregated data. Each of these areas is actually made up of sensor agnostic data from multiple sensors in that area. And the way that's done is using this graph. So here at the bottom, each sensor has a node, and each of those nodes feed into an area. So whenever the node data gets updated, the area gets updated. And finally, that feeds into these high-level areas, which we see on the map. So that's a very high-level description of how we created this digital twin. And now if you stick around for the full webinar, Benjamin will go into detail about how he created all of these in detail, and he'll also share all of the code that we used. Thanks for watching. All right, so that was a really quick overview of what it is that we're going to build today. That was our digital twin visualization from the Things Conference 2022. And today we are lucky enough to have Benjamin Kabe with us, who is the principal program engineer at Azure IoT. Let me just bring him in really quickly. Here.
Hello.
Hello, Benjamin.
Hello.
And so today Benjamin's going to go into depth. Benjamin's going to go into depth about creating this visualization, and then you can ask him questions about how he did it. So what we really want to highlight here is the ease of integrating the Thing Stack and Azure IoT. That integration is native, so you just enter a little bit of, basically you put an API key for Azure IoT Central into the Thing Stack, and then all of the data automatically gets piped over. And then from there, you have a lot of powerful tools that are really easy to use within Microsoft's subsystem in order to act on that data. So Benjamin, where are you joining us from today?
From France, where it's already getting dark. I guess the winter is coming.
Yeah. Amsterdam is a little bit warmer, but yeah. So let's see. So today I wanted to ask you the question. I made a little slide. What is the metaverse? And I hope that you've prepared some cool philosophical answers to that question. And then we'll go into the webinar and explain to us how we created this visualization.
Yeah, philosophical or controversial. I don't know. Like, we hear a lot about the metaverse, of course. And I'm sharing my screen now, so hopefully you guys can bring that in. We hear a lot about the metaverse, and at best, maybe you find this whole idea and this whole buzzword just like meaningless. And worst case scenario, you may actually think that's scary. Like, we're all going to be avatars in a digital world, and it's we're gonna lose all purpose in life. To me, I don't mind the keyword. What I care about is what's behind, right? And if we turn to Wikipedia, one definition for the metaverse would be essentially the kind of like what we see in movies such as Ready Player One, right? Like this idea of talking about like futurism and science fiction, where essentially we iterate on like the definition of what the good old internet is, and we take it to a more virtual, like virtual world and immersive world kind of next step. And that brings a lot of like virtual reality, augmented reality scenarios. That's one definition, the one at least that's more geared towards all things science fiction. I don't think that's what we're going to talk about today. Another way to approach the metaverse, and that's also from Wikipedia, is just to think about it as a network of 3D virtual worlds focused on social connections. That's also one way to look at it. I'm not sure I agree entirely with this particular definition. Like, yes, there is a strong focus on social connections and social interactions. There's also a strong focus on 3D, and to me, I mean, it's more it's broader than that. Like the metaverse is like, if we think about scenarios for it, like there's essentially I would think three pillars or three ways to look at what it is. What is this next iteration of the internet, to my point earlier? One is what I would call the consumer metaverse. Think like online gaming, Second Life kind of experiences, maybe, where essentially there is a more seamless transition and integration between the kind of interactions you would have in real life and the ones you would have through video games and things like that. And then there is the enterprise metaverse with, I mean, arguably we go from the more the more general audience kind of scenarios to the more useful potentially ones, right? So enterprise metaverse would be how do you make social interactions in the workplace? How do you make them better? Like things like we've all experienced that with the pandemic, really. Like we all do Zoom meetings and Teams meeting all day long. It works reasonably well, but there are some interactions that we just can't have through a video interface and a text chat, right? Someone is presenting during the meeting, and you want to whisper to the ear of the people, the person or the couple persons around you to have a side discussion. You don't want to disrupt the meeting. It's probably not like the most important thing that you want to discuss, but still you want to be able to do that seamlessly. So like there are tools that starts to pop up to make that more seamless and to have like such experiences in the so-called enterprise metaverse. And then there's all things industrial, and this is really where we take this is the scope of today's webinar, and this is where essentially you take hopefully we've started tackling the IoT problem, right? And now it's now been a few years, arguably a few decades, since we are able to feed data and real-time insights from sensors deployed on the shop floor, etc. And we feed this data to good old like enterprise systems in the cloud or in backend servers. But how do we make all those sensors seamlessly interface and integrate with all those legacy systems that are already there, right? How do I query how do I merge everything coming from my supply chain management software, my sensors, my workers' schedules that I manage in some production management software? Like, how do I make all that again seamless and have this experience where the physical world and the digital world really start blending, right? So that's sort of my long philosophical or not so philosophical introduction to what's the metaverse. But yeah, really, there's lots of use cases out there for making it really, really concrete, right? It's predictive, remote and predictive maintenance, everything healthcare, retail scenarios. Like you walk into a shop and there's suggestions that are being made to you based on like what you are, what's available from your own network, social network, but also where you physically stand in the retail store and so on and so forth. And there's your manufacturing. So the one point that I really want to make clear, and Ben already sort of hinted at that, it's not because it's the new buzzword on the blog that it has to be bleeding edge tech, right? It might be to some extent if you really look at like augmented reality and HoloLens, sort of like augmented reality experiences, but most of the technology that powers the metaverse and digital twin scenarios, it's not new, right? And it starts with being able to like make sense of all the data, all the information. It's a problem that's as old as IT probably, but it's even more real and even more of a problem when it comes to aggregating data coming from many different sources and many different sensor manufacturers and so on. So defining ontologies, right? Like having ontologies for describing the capabilities of your different sensors and devices, but also leveraging existing ontologies that might already be there for the rest of your system that might not have anything to do with IoT sensors. But all of that needs to be you need to be able to model the relationship between all those entities. You need to be able to sort of persist the data in graph databases, time series databases. Like you want to be able to navigate all the different relationships between the different entities. Again, right? Like if I walk onto a shop floor and I want to know whether some machines need fixing, then I really want to like query the metaverse with a query such as metaverse, like I'm here, what are the machines that are around me, like spatially, and for all those machines, is there any one machine that has an alert that requires a human intervention kind of stuff, right? And for that, like, and I need what I just enumerated, ontologies and the databases to store the data, and then of course you need to feed the metaverse with information, and some of that information will certainly come from physical things, and we're going to see how we've done that for the LoRaWAN sensors that we're scattered all across the Things conference venue, and potentially you may actually decide that the sort of the cherry on the cake and one way to interact with the metaverse is going to be through augmented reality and virtual reality experiences, but it doesn't have to be, right? To like the definitions I was going through at the very beginning, they were putting an emphasis on 3D and digital worlds. It doesn't have to be, but the good thing is if you have such scenarios, then it's actually really easy to implement because all that's needed is already there. You already have the data. You already have a way to easily query it. So that's the idea. So in a nutshell, building a digital twin solution or a metaverse, like starting thinking metaverse, it's really just about making sure that you can contextualize easily your data, and you want to be able to interact with all the increasing amounts of data and insights that modern systems, including devices and LoRaWAN sensors and whatnot, are generating, right? And that's really all there is to it. So how did we build that for the Things conference and for this particular demo and this particular giant digital twin that was featured at the conference a couple of weeks back? Let's go. Essentially, Ben's video was actually really good. I'm not sure I will do any better. I hope so. But let's just go through the whole workflow that Ben covered. And I'm just making sure that there's no questions in the chat so far. There aren't, but please make sure either on LinkedIn or YouTube, please comment and we'll address the questions either on the fly or towards the end of the presentation. So some of the things I will show will be familiar to some of you, some may not, but we're going to walk through the whole thing, and in any case, it should make a lot of sense actually. So this is the particular, this is the Things Stack console for where all the sensors that were deployed during the conference and hooked everywhere into the venue, this is where those sensors are calling home and sending data to, right? So right now we are seeing the live stream of data from this, dozens and dozens of sensors, really. Some of them would be like monitoring the humidity, the temperature, some of them the air quality, things like that. Like Ben mentioned, this particular instance and this particular tenant of the Sync stack is already configured to talk to IoT Central. So it's actually connected to a particular instance, and it's anytime there is an uplink message sent from a device, it's being forwarded to Azure IoT. Anytime a new device gets provisioned, it gets provisioned into Azure IoT, and so on and so forth. So all those devices that are chatting in real time, we will actually see them live in Azure IoT Central as well. So I'm going to pick one. Let's see about this guy. Oops, I wanted to copy the name just to have it handy. So yeah, that's the one that ends with 00091. If I switch to Azure IoT Central, you can see that there's lots of devices, actually the same devices that we would have seen in the ThinkStack console. And hopefully those devices, like the telemetry, start showing up in real time. Let's see about that. This particular sensor, it's there. It's actually, like Ben mentioned, it's actually been modeled, and there's actually a template that describes what are the capability. Oh yeah, the screen share. That's interesting. I hope, is there anything I can do on my side?
Maybe it's the resolution. But
well, actually switched on. Let's see, because I switched to 1080p on purpose. Let me see if I switch to 4K. That's not better, is it?
I would think actually that a lower resolution might. Yeah, I don't know. This is.
I'll stick to the other, right?
Yeah, I would say the lower resolution for sure.
Yeah, that's really unfortunate. Let me see. I'm gonna make it as big as I can, but it looks like it's crazy pixelated, right?
Yeah.
But it wasn't with the PowerPoint though, was it?
No, with the PowerPoint I can see. Maybe it's the. No, it looks like.
Could it be the?
There in Restream there's usually a little settings button, or if you press S, and then maybe you can see the quality that it says it's streaming at.
For video I'm sending at 720p, and I don't think there's anything else I can change. Could it be that it's a private session? Let's see. No, that's not what it is. Wow. Let's see if I stop sharing and start again. That's really unlikely. That's going to. Or I'm going to share the window, maybe. Let's see. Can you put it on? That's not. Oh, that might be better. Is it? Oh, and PowerPoint was also low res. Says. Yeah, I'm not sure there's anything I could do on my side to fix it.
Yeah, for now let's move ahead, and if people have questions like about what exactly we're showing, I think the point is more where we're entering information than what the actual information is, and you'll share all the code afterwards. So even if you can't see now, we'll post all of the code and the steps so that people can follow along as well afterwards. Now I can at least read the
it looks like it's slightly less terrible. Really sorry about that.
All good.
Yeah.
Go on.
Okay. I'll try to make everything as big as I can. So let's see. This device that we saw literally like communicating literally seconds ago, or now maybe minutes, it's there. It's there, and we can actually see the data coming in, it's local time here. It's actually sending data every 5 minutes, it would seem. And we can, in IoT Central, should we want to, we could actually set up some like fancy dashboards with like the history, displaying the last value, having some charts and so on and so forth. But the what we really care about is actually taking all those, like this particular sensor and all the sensors we have and we had in the venue, and have them like be part of the a digital twin solution, right? So one thing we do for that is that we actually set up a we export essentially all the data that's coming into Azure IoT Central, gets like anytime there is a property that changes on any of the sensors/devices, the data gets posted to, like Ben mentioned, to a webhook that takes essentially it's JSON data, right? The JSON payloads from the different sensors, and by the way, it's already decoded, right? The things stack, and with the device registry is already taking care of decoding the opaque payload from the sensors, and what we get is like actual temperature, actual humidity, and we send this data to Azure Digital Twins, right? And we essentially just call virtually an API. I realize that now that I'm sharing my only a window, I need to switch back to actually share my wall screen. Can you put that on again, please? And so the this webhook that we are, well, it's really, really bad. I'm sorry about that. I'm actually tempted to switch to another browser. Let me try and do that real quick. I'm actually only use it for the screen, if we can try and do that.
Sure. And I think you'll have to leave and come back in the other browser. Is that how you're going to do it?
How about that?
I'll entertain people here while you figure it out. Let's see. Do we have any important updates? Okay. Well, Benjamin is figuring out screen sharing. I'm back. Let's see. I can make a quick introduction to the Things conference while we're here. That's the picture behind. The world's largest digital twin, the sort of inspiration for this webinar, we did at the Things conference last year. The Things conference is the world's biggest conference on LoRaWAN. And this year, or next year in 2023, it'll be the 21st and 22nd of September, if I'm right. Also, if you're interested in digital twins in general, in LoRaWAN in general, always check the links below. We've got lots of resources where you can continue to learn about LoRaWAN. On the Things Network, we have a whole section dedicated to using LoRaWAN to create cool cases, and lots of further learning. So we've got the Things conference, check that out. The Things Network Learn, check that out. Ooh, there's a link. And let's see, I can see Ben in the backstage there.
It's not better, is it?
That's
wow. I actually switched browsers and stuff, so that's...
Yeah, I think it's not that. Sure. It's maybe it's just the way that the screen sharing source works here in Restream.
Yeah, but that's even worse than earlier. Meh. Okay, I'll try and keep moving. So I'll actually refrain from showing some of the code that I wanted to show, because it's highly unlikely that it will be useful. But from Azure IoT Central, thanks to the data export feature, we actually end up being able to synchronize data with Azure Digital Twins, right? And Azure Digital Twins is a service in the cloud that you that takes care of historizing all the data for you, all the data for your sensors, essentially, or actually potentially more, because a digital twin, typically we think about it as being the digital replica of a physical thing slash sensor, but it can be a digital replica of anything, really, right? It can be the digital replica of a person. It can be the digital replica of a building. The building itself, right? The building itself is not a sensor; it's a building. So all those twins, they can live in the Azure Digital Twin service, and you can interact with them through an API. Or through potentially through a web UI, which here we have, and I'm gonna let's see. Oops. What we see here from a distance with a handful of pixels. Sorry about that. That's the model of the different entities that we had for the Things conference. And the Things conference is a conference that happens in a building, right? So that's the building entity over here. And the building, it contains different exhibition areas. There is the food area, there is the sponsor area, there is the main stage, there is the theater. Like those are the kind of high level entity classes, you could call them even, that we wanted to manipulate as part of this solution that we wanted to build. Like what we wanted to build, like Ben was showing in the 3D live visualization, is really like we have a venue, we have tons of visitors, and we have the rooms getting filled up with participants and speakers, and the air quality potentially dropping. Like, can we monitor all that in real life? And can we actually query the environment to be like, hey, from 11 a.m. to 12 p.m., what was the room in which the air quality was the worst? Kind of query, right? That's really what we wanted to enable. And or potentially have a live 3D visualization as well. So yeah, exhibition areas. Each exhibition area contains potentially booths, right? And so that's another class, another entity in the system. And every exhibition booth might contain a one or many sensors, right? So there is a relationship there as well. Sensors could be, and those are the green arrows over here. I'm actually starting to think that it's actually a really good exercise that you don't see the whole thing, because you have to pay really good attention, and I have to be extra clear too. Those green arrows, as opposed to the yellow ones earlier, those are for symbolizing inheritance, essentially. So all the like the exhibition booths, they contain sensors, and sensors may be of different types, right? They can be Tineo CO2 sensors. They can be, I think we had Dragino temperature sensors. We had filling level sensors from another manufacturer, and thermocone, whatever sensors. So all this has been already modeled, and for each of those entities, we've pre-modeled the capabilities, if you will. Like a temperature sensor from Dragino would expose a battery level, would expose a temperature in Celsius, would expose a humidity in percents, and stuff like that, right? And so this is the our class diagram, you could call it that way. And then we can switch to this other tab over here, which shows us the actual instances of the twins in our system, right? And I can actually write like pretty much like SQL code, right? Like right here it says select wildcard, select star from digital twins, and if I am to perform that particular query, I'm going to actually retrieve all the entities that are in my system, whether they are booths, sensors, exhibition areas, whatever, and I'm also going to retrieve all the relationships between them, right? And so that's that's our graph, and it's highly dynamic. It's going to be like in real time as new sensors pop up, as new sensors disappear, as operators of the solution start associating the sensors to different sections and different areas of the building. The like new entities will appear, their relationships will evolve. And if I am to look for the sensors that we were looking at earlier, it should actually show up in the system, right? It's highlighted over here. I know it's small, but what matters is the fact that really like there is this sensor over here, and it's part of this giant graph, right? This giant graph where at the center of it, really like if you cannot see it, but at the center of it is actually the twin corresponding to the venue itself, right? And from there, we have all the different things being reachable. And one such would be the sensor itself, where we can see all the details, like in real time. The through this particular UI, we can interact with the twin and essentially make sure that data is being fed properly from the Think Stack to Azure IoT Central to Azure Digital Twins for this particular twin. For other twins, data might be coming from legacy systems, right? There might be some batch processing of Excel spreadsheet happening every night and updating the some metadata for some of the entities in the system that might not, like, there's no sensors for them, but still it might make sense to make to keep some properties up to date, right? And so through the UI or through APIs, we can query the system, right? And we can query the system for, like I said before, doing things like, hey, give me all the sponsor booths for which the humidity is over 80%, right? That could be one query that we write. We can also go back in time if we leverage services like Azure Data Explorer. We could also like have the time aspect also, and we could go back in time. So yeah, one thing that we want to do from there is to actually visualize the data, and ideally we want to write as less code as possible, because frankly, once the entities have been modeled, like all the capabilities have been modeled, all the potential relationships have been modeled, like the thing that most people will want to do is create some kind of dashboards where they just leverage the kind of it's the good old like Microsoft Access days, I guess, right? You have some relationships already established. You don't necessarily know much actually about SQL and whatnot, but the relationships are there and they are browsable. And if your ontology has been well designed, it's actually pretty straightforward to start creating visualizations such as the one that we're going to see here. This one actually doesn't look so bad, even pixelated. This is actually the venue, the Things conference venue. I took Vinke from the Things Industries. I think he worked with the organizers, and I think Ben, you actually helped there as well. But luckily, the organizers of the owners of the venue, they had a CAD model for the venue that they could send over. So we took the CAD model, we just uploaded the model like straight into the Azure Digital Twins 3D Scene Explorer, and then we end up with a 3D model that's like here. It's actually pretty reasonably straightforward because it's just a building, it's just boxes, but it could be robotic arms, it could be anything really. Potentially, it could be animated, it could have really fancy textures and so on. And the thing is, it's a 3D model. So a 3D model contains like 3D objects, right? And all those 3D objects, in our case, they actually correspond to things that have a representation in real life, right? If I am to actually switch right here to the build mode as opposed to the view mode, which I were earlier. In the build mode, I can actually navigate and overlay and over all the different 3D objects in the 3D model, and I can decide that some of them I actually want to like have them replicate and mirror the status of a particular twin, hence potentially a particular physical entity, right? So if I am to pick, let's see, this wall over here, I can actually create a new visualization where I'm going to say that this particular wall aims at displaying data coming from one of my twins. And I'm again going to take the very same twin we were looking at earlier. And this particular twin, so I'm going to create the visualization, and then I'm going to configure it, right? And I'm going to associate a so-called behavior. And there are some behaviors that have been modeled already. Essentially, what is a behavior? It's deciding on a particular visualization for a set of properties. So most sensors in the system, in the solution, most of them, they expose some form of temperature and humidity. So there is a generic visualization that may exist for temperature and humidity, right? And this is the one that I have already created here, right? And so I'm associating this particular behavior to this particular wall in the 3D world. And then if I switch back right here to the view mode, then I still have like my 3D building, but now the wall, which is right here, I can actually click on it, right? So I can click on the wall, just making sure that, so that's the wall that we saw earlier. And it's actually showing, not only is it green as an overlay to sort of indicate that it's in a reasonably good temperature range as of now, but then if I click on it, there's actually also some nice widgets and some nice dashboards which I can use to monitor in real time what's happening to the sensor. And interestingly, if I am to manually override the data from this particular sensor, if I go back to my Digital Twins Explorer, I can decide over here that the temperature is actually 80 Celsius. And so for the time being, until the sensor actually communicates again in the system, it's said that it's really hot, right? And so if I switch back, right now, the temperature says, and yes, I know it's really small, it says 80, and the wall behind is now yellow because like 80 is, I guess, warmer than 20 point something that we saw earlier. So that's, that's one way to visualize the data. And of course, there's APIs to manipulate and to interact with the digital twins environment. So you could also think about other kind of visualizations. You may have your own CAD software, which you want to script so that you can visualize data in real time in your AutoCAD or Blender or whatever. You could do that too. Or one other thing that you can actually script and program is the graph itself. And what I mean by that is that one thing that show here that we can see here is that like there are different sensors, right? Like some of them, let's see. Yeah, there are different booths in the venue. And those booths, like we've seen earlier when going through the class diagram, sort of, those booths may contain different sensors. So that's interesting because that means that we may decide to visualize in our 3D model or anywhere really, we may care about the values from the sensors themselves, but more likely we care about the values put in the context of where, like, if we have several sensors in a particular area, in a particular booth, it's very likely that what we care about is actually the temperature of the booth itself. We don't care about like and we don't want, frankly, to go and like figure out which sensor has been deployed where, and we keep track of which serial number that is, so that we can query that and we keep track of that in the system. No, the Azure Digital Twins and the Digital Twins graph already has and already holds that information. So we actually want to like query the booth as if it was some kind of virtual sensor, pretty much. And so what's happening under the hood actually is that whenever sensor data gets updated into Azure Digital Twins, there is a hook that gets triggered, and there is a hook that listens to changes to sensors, temperature and humidity, and so on. And whenever such changes occur, we actually look and we check if the sensor belongs, and if the sensor is associated to a booth, then we bubble up the information. We're actually, okay, the temperature of this particular sensor, like the sensor reports the temperature has been updated. Let's go up one level and let's check at the booth level what are all the sensors, including the one that just got updated, and let's compute the average temperature of all those sensors, and let's put that temperature as a property of the booth proper, so that we can, like later on when we care about the booth temperature, we have like just one query to write and the data is already there. We don't have to consolidate and compute the averages all the time. It's only been done smartly, hopefully, only when the temperature actually changes. So that's another thing that we did. And with that, I think I've actually pretty much covered the sort of the end-to-end scenario. I'm really sorry again about the screen share quality. Not sure how we didn't catch that earlier, but anyhow, if there are any questions from you, Ben, or from anyone else in the chat, we'd be really happy to take them.
Yeah, I have a question already. So one thing that we're kind of addressing now in the Things stack is the fact that all of these different manufacturers, they decode data in different ways. So some sensors, for example, in the decoder that's defined in the Things repository, sometimes it's called temperature, for example, the temperature data. Sometimes it's called temp, sometimes it's temp C, sometimes it's temp F. How in these graphs did you account for different naming schemes?
You don't have to share my screen again because it's actually not any better. So that's actually from a distance. That's the code for the hook that I was mentioning earlier. And to answer your question, for better or worse, now it's done manually, and it's like literally there's one line of code that says if there is an attribute that's either called TMP or capital TEMP or lowercase TEMPATURE, etc., like all of that has to be a temperature. And so the hook actually takes care of making sure that at the end of the day, this is going to be seen and perceived as a temperature. But someone will have to take that to the next level, and some of that might be done by you guys, I guess, in the device registry and so on, by means of adding, like, not only doing the payload decoding, as in taking binary data and turning it into JSON like objects and properties, but also making sure that the metadata and the units are all also there, so that we don't have to do that manually further down the road, because someone has to do it, and it can be sadly can be pretty error prone.
Okay. Yeah. So right now it's just user-defined cases that are looking for these particular things,
yes.
right? Yeah. But that is it's on the roadmap now for the device repository, is what we call standardized payloads. So we'll then allow manufacturers to say, okay, this is the data as we decoded it, and then the next step will be, this is the standardized payload, where we have a predefined sort of codec for sensors and manufacturers can say, okay, in this codec, this is this temp C, this is, and then we also have like different types of sensors, so underground temperature, overground temperature, water temperature, things like this, and we're right now defining that so that hopefully we can roll that out pretty soon. Let's see if I had any other questions. I remember we only had the 3D model in like as some kind of funny CAD format. What types of 3D formats does the 3D
I think it was the DXF that originally we got from the venue. It wasn't like the cleanest file because there were like tons of objects. At the end of the day, the tool that I was showing before under the hood, it uses Babylon as the JavaScript library for visualization, Babylon JS, and the file is the GLB or the GLTF format. So it's at the end of the day, like it's an open format, which, like I said, may include animations, which will play, and which may also include like fancy textures. There's only, I think, a limit as of now that it has to be less than 50 megs in size, which, like, if the model is well designed, 50 megs takes you really far, actually. So
yeah. Cool. Let's see. Well, I hope that that in the recording we were able to capture some high resolution stuff. But just in case, are there any resources that you can share which also can sort of walk users through creating these types of things
I don't have them handy, but maybe I will send you a couple links that you can put in the description of a YouTube video. But in like what I think I said and hinted at in the quick PowerPoint deck at the beginning is that, like, the tech for being such, like, yes, there is a bit of eye candy to the 3D model, but apart from that, everything else, it's pretty old tech. Like there are some tricks in terms of making sure that it scales, of course, in terms of like if you have like billions of devices and stuff, under the hood it might be complex, but it's pretty, like, where I'm getting is that the pointers and the links that I will be sharing, those are the super basic tutorials for Azure Digital Twins. Like this particular demo is just like a tiny bit more than just the regular Hello World for Azure Digital Twins. So yeah.
Okay. So I will collect the presentation link and any other like kind of guides that I can share with users who want to try Digital Twin. It doesn't look like we have any questions in the chat here. Is there anything else I wanted to ask? I know that the way that we came up with the idea for this world's biggest digital twin was from the space station. The space station example that was an earlier showcase from Digital Twin. Maybe there's also some information about how that was built that users could follow along with.
Yes, and there's also a demo available online. Like if you navigate the documentation pages for Azure Digital Twins, and particularly the 3D scenes sections, like it actually takes you to the ISS demo that you're just mentioning. Yes.
Cool. Yeah, the ISS demo is that's all populated with live data as well, I think. So you can go and you can see like the temperature in various parts of the space station. We'll share all of those links. I guess that wraps this up, unless we have any other questions, which doesn't look like we have. Is there anything else that you want to share before you leave us?
No, well, except that I'm, really sad and sorry about the screen sharing situation. Like you said, hopefully the recording will be better. I doubt it, but we'll see.
We'll see. The important thing is to get that information out, and I think there's some other guides about how to do that, which people can follow along with. Also, you'll share the code that we used in this, and we can share access to the visualization so people can go and play with it themselves and see how it builds. Cool. Thanks a lot, Benjamin.
Thank you.
And thanks again for sharing all of your knowledge. if we have any questions from people in the future, we'll point them your way. Follow Ben on Twitter at CartBen.
Yeah, or Mastodon. I should have put that too, but the handles for the Fediverse are a bit longer. But yeah, I'm there too. Yeah.
Cool. All right. Well, thanks a lot, Ben. I'll let you go.
Thank you. Bye.
Okay. For those who are still here, that was Benjamin Kabe from Microsoft Azure IoT, sharing how we built the world's biggest digital twin at the Things Conference 2022. I want to point out again that the Things Conference 2023 is going to be in September, and I think that there's a link in the YouTube description to that. There it is at thethingsconference.com. You can find all the information about that. We will surely do this again, where we basically take this sensor agnostic, we take sensors from all of our partners, and then we pipe them into the Things stack. And then from there, we connect it to Azure IoT. And then we have this big 3D model that you can walk through and see how many people are in the rooms at the venue and things like this. So that was a really cool demonstration to get to do at the Things Conference, and to kind of give people an idea about what kind of like powerful visualizations you can really easily create using the Things stack and other data visualization tools. If you want to get started with the Things stack yourself, we have the Things stack discovery tier. There's a link, like everything else, in the description in YouTube, and so you can get started like building your own LoRaWAN use cases for free. There's also the Things network, of course, and we've got lots and lots of learning resources and further information that you can follow up on the Things network website. Anything else that I need to share? I don't think so. I think I've pretty much covered everything that I wanted to cover today. Please don't hesitate to reach out to us if you have more questions about this. If you're interested in digital twins, register, and we will see you at the next webinar. And if we don't see you at the next webinar, I hope we see you at the Things Conference 2023 in Amsterdam in September. Thanks a lot for watching, everybody. Bye.